Hi everyone, this is Professor Benjamin, and the purpose or objective of this video is to give you an overview of the Session 1 PowerPoint. So if you are in Canvas, you will then open, and I'm going to go right here, you would go to your modules area, and it would be under Session 1, and right here will be the lecture, this lecture. The OER textbook is here, and of course you want to read your description or your to-do list to find out what parts of the chapter you want to read, and then right here is the PowerPoint. So if you want to click here, this is the PowerPoint that I'm going to go over in this video right now, and then you have additional videos here, and these will help kind of elaborate on some of the ideas that we're going to talk about in this PowerPoint presentation. For example, feedback loops, scientific method, ecosystem services, and ecological succession. So here we go. So the first slide here, we're going to talk about the environment. So of course, the environment consists of the physical environment, the chemical environment, and biological factors, or the biological environment. Environmental science is a study. It studies all the aspects of the environment. I majored in environmental science because I get bored very quickly. So it gave me the chance to be able to study all different topics. So when you are an environmental science major, you take your chems, your bios, you take your organic chems, your college chemistry, you take your calculuses, you take microbiology, you take hydrogeology, you take ecology. So you take tons of different courses across a wide breadth of areas. You can take marine courses. I've taken coastal processes, how beaches are formed. So there's like tons of classes that you could take across the board. And that's why I liked it, because I didn't want to study one thing in a super heavy manner. I like to study all the different sciences, and environmental science incorporates all the different sciences within one branch, specific branch. So then what happens is a lot of times after you've taken the basic environmental science degree, then my master's, I went into policy. So you can go into all different kind of fine tuning which part of the environment you really want to kind of zoom in on if you want to do your master's or doctoral degree. One area that you could zoom in on is ecology. So ecology is one of the disciplines in environmental science, and it studies the abundance and distribution of organisms. And if you look down here, you can actually see additional notes that I have on these slides. So, of course, it's really important for us to study the environment, especially with what's going on in the world today. We have climate change, right? We are running out of resources very quickly. We have a huge waste problem throughout the world. We have an ozone layer issue. I mean, it's endless how many issues we have in the environment, plastics in our ocean. I mean, it's just endless. So that's why this course is so important. And you'll realize throughout the whole entire course how much the environment plays a role, and even the sociological aspects and psychological aspects play a role in how we view the environment. So resources are dwindling, behaviors have changed. Even though scientific studies have increased, we have continued to abuse the environment, and it's really odd because we have all the factual basis, but yet we just turn a blind eye to it. I mean, if you look at recently with floods and tornadoes in our area, hurricanes, the strength of hurricanes, it's just unbelievable, and we have all of the science behind it, but people just choose not to agree with the science. And so we have new knowledge, and we have, though, even though scientific studies have increased, we have a subset of people in the world who are looking into forestry and replanting of forests. I follow a girl on TikTok who her whole entire summer job is to plant trees throughout British Columbia. It's really a cool job. It's not an easy job, but it's a really cool job. We have put limits on fishing in our fisheries so that we can continue to have ample seafood available, although we're running out of these sources. So this just gives you a little bit of history about our how we have kind of evolved in the environment. In the 1950s, 152 million people in the United States, and this is when housing boomed. We cut down a lot of forests in the United States, and we built a lot of subdivisions. So we started that whole idea of suburbia. At this point, we weren't really thinking. We weren't really thinking about the environment. And then, of course, the population exploded. We're at about 7.9 billion people. We were at about 8.2 billion, and we've lost a lot of people due to COVID. But we still are exceeding our numbers. And we'll talk about that when we get closer to population, about carrying capacity and exceeding the carrying capacity line. But we are continuously booming in terms of human population, which then of course affects the environment. Let's talk a little bit about ecosystems. So ecosystems include the living and non-living parts. So all organisms and their physical and chemical environments is what we consider an ecosystem. And we have our living and non-living parts of the ecosystem. So the living things we call biota, and the non-living things in the environment we call abiotic factors. And ecosystems are integrated systems, meaning if we throw one part of the ecosystem off, another part's going to get thrown off as well. So it's an integrated system of living and non-living parts. Energy and matter must flow in and out of the system. So it's always a continuous flow of energy. If we mess up that energy or that vibe, we can throw an entire cycle off kilter. And people are very worried about this in terms of our water cycle. And our water cycle affects our climate cycle. And so that's really important. And we, of course, will talk about that when we get to water and we talk about water cycles and climate change. So we have this integrated system where sunlight and materials like carbon and nitrogen and water go into the system. They are transformed and an exchange of matter and energy between biota and abiotic environment. And then, of course, we have an outflow, which is heat and materials like carbon, nitrogen, and water. Notice what goes in is what comes out of the system, and then this goes back into the system again. So it's like a closed loop system. The problem with how we live today, in terms of like consumption and waste, we live in a linear system where this end product is not put back into the original environment, so it's not closed loop. So ecosystems are either really tiny or really big. And so we have something that could be the size of a rotting log all the way up to a continent. So ecosystems, we can consider that just like, you know, I have like a little terrarium, right? And inside there, I consider that an ecosystem, right? But we can also consider an entire continent an ecosystem. So ecosystems can be very small or they can be very large. And here's just like a good example of that. And ecosystems provide humans with a lot of different services. They provide us with what we call provisioning services, regulating services, cultural services, and supporting services. They provide us with all of these different things. And so without ecosystems, we can't have these things. And I included, you saw in the modules, a link to another article based on ecosystems and what those provisioning services are, and you can take a look at those. But here's just a really good slide that kind of talks to you a little bit about the ecosystem services. So provisioning, they provide us with water, food, fiber, etc. They regulate, they provide, they regulate the climate and water flows and disease. Culturally, they provide us with aesthetic beauty, recreation, etc. And then supporting services, they provide us with soil, formation, pollination, nutrient cycles. So they provide us with a lot of different services. And a lot of times we forget to think that the environment is keeping us alive. And without it, we could be in a lot of trouble. And so these additional slides go into more detail with what each one of those services is. I want to move here though to the ecosystem function. And of course this goes into a little bit of physics, which is matter and energy are neither created nor destroyed. Ecosystems are open to gains and losses. And so that means they're always open to gains and losses. Ecosystems processes are self-regulated, meaning we have tried to regulate ecosystems and we could do it to a certain extent, but we can't fully regulate an entire water cycle. Humans cannot get in there and fully regulate something. And we've talked about this before, like where we're going to try and stop climate change by shooting things into space, etc. But humans will probably never be able to regulate because there's just so many details that we don't know of how things bounce off of each other to make it work. One thing that is really important about ecosystem, change is essential and inevitable. And this goes against humans. Humans do not like change. We like to think we like change, but when change happens, we don't like it. And we could see that even in terms of sociological aspects of our nation right now, right? Is that we think we want change, but then when it comes time for the change to happen, all of a sudden everybody's like, oh, I don't want it to change. I don't want this. I don't want that. So this is the same thing, but the problem is environments are constantly changing, and humans will either have to adapt to those changing environments because it's inevitable. And we have exacerbated some of these changes, but we are either going to have to adapt to them or we'll die. And these are just examples. I'm just going to kind of skip through a little bit. I want to go over this real quick because we only have a couple minutes left, but I want to go over what homeostasis is in the environment. And homeostasis is a balance. So it's when systems adjust, right, to reach a balance. What we want a balance in the environment, okay? And the systems adjust by using feedback loops, either positive or negative feedback loops. In terms of this class, a negative feedback loop is actually a good thing. It's trying to get the environment back to its original state. So that's a really hard concept to understand and realize. But in this class, a negative feedback loop is something we actually are pushing towards in most cases. I'm not going to say every case, but in most cases. A positive feedback loop keeps the system going within that change, meaning it probably keeps the bad thing happening over and over and over again. And we don't want that. We want it to come back. So I'm going to show you two examples. Here's a good example of a negative feedback loop. And as nutrients increase, algae growth increases. So as nutrients in the lake increases, algae growth increases. It then, of course, sucks, depletes the nutrients, and everything dies in the pond or lake. And then what happens is there's no more nutrients left for the algae to use, so the algae dies back. And then that cycle happens again. So that's negative, meaning that we want the algae to die because we want the environment to come back to its original format. So that's a negative feedback loop. A positive feedback loop keeps enforcing the change. So for example, we clear cut a forest, and then you can see here we clear cut a forest, and then guess what happens? A heavy rain comes, then there's a mudslide. The silt then ends up in, it accelerates further forest loss down below, and then because this is like a mudslide, it kills all the trees below as it rushes down the hill. That then ends up in a waterway. The waterway then becomes suffocated with silt. The silt kills coral reefs. So it just keeps this whole cycle going. The best way that we can make this positive into a negative is to then plant a forest again on this hillside. And that would be making it a negative feedback loop instead of a positive feedback loop. We talked about this, that change is an inevitable and essential. We actually need change to happen for the environment to continue to succeed. Succession is the next topic I want to talk about. There's primary and secondary succession, and you're going to read about those in terms of this course. So ecological succession is the structure of biological community changes over time, and there are two types. There's primary and secondary succession. So primary succession is the process in which plants and animals first colonize a barren habitat. On a barren island, a seed takes root and begins to grow. Secondary succession, on the other hand, is when the growth in a community such as an area which was previously occupied, inhabited, and that has primary vegetation but got disturbed or damaged. So for example, what recently happened in the city of Philadelphia with floods, etc., tsunamis or a fire, or a tornado comes through, it rips up trees, and then guess what? A different tree type starts to grow there. That's what we call secondary succession. Okay, so primary succession, barren land. Secondary succession is when a natural occurrence happens, like in terms of like climatic event or a physical event happens on the earth, and then it changes. So here is a good chart of what I mean by primary and secondary succession. So I am going to have to, I think we're almost to the end. I'm going to make another video, a part 2, in 1 second. So look for part 2 of this video when I go over the scientific method.